Okay, so assalamu alaikum sir, I'm Mohammad Abrar Jain, and today I'm presenting my project, a universal Bluetooth robot controller. In robotics, a common problem is the lack of a standardized interface. Every robot usually requires a hard-coded specific remote. My objective was to create a scalable software-defined controller that can manage multiple robot profiles securely, connect efficiently using Bluetooth Low Energy, provide a customizable control interface that adapts to different hardware requirements. So if we see, my application is mainly made based on natively in Kotlin, and I have used Jetpack Compose UI toolkit for my visualizations and stuff. So if I run the application, so the application starts with a login page where we enter our where we enter our email and password. So if we go here, I have defined the here I have implemented room database for local persistence. Instead of volatile memory, I define a data access object that allows me to perform asynchronous CRUD operations, create, read, update and delete operations. This means the user's robot configuration, specifically their MAC addresses and names, are permanently saved on the device. If we click add, then scan to the point, like add and scan, as I am in the desktop application emulator, I do not have Bluetooth connectivity, but I'll show it shortly. Let me just demonstrate the application first. So this is from the hosting from my own device, and if I run the application here, I think I've stopped this first, then run this one and run this one. So now I am using it for controlling it from my phone. So if I do test, if I log in from here, I can access my surrounding Bluetooth devices from my Bluetooth, and I have attached a ESP32 board here, and I will use its Bluetooth module to run some basic code. So if I go here and scan for devices, and if I just run this here, as you can see, my application has already been, my ESP is already showing in my application, and this is my television and other Bluetooth devices in my surroundings. So I'll select the application, and if I go there, it says connected and ready, and in the Arduino IDE terminal it also says app has been connected. So if I have already added some buttons here, and if I just demonstrate one, for example forward, and it sends F. If I do this, if I press the forward button, I get a raw input F and the custom command F. The F here will be used as used in the code or my robots program, and in my robots program the F will be defined as forward. Same goes for other stuff, like if I have a humanoid robot and I want it to dance in a hard-coded way, I'll just press this dance button and it will dance on its own. And there is a joystick here. The joystick measures the X and Y coordinates simultaneously and feeds the data to the Arduino or the ESP in this case. Yes, the joystick is pretty much responsive and sends command to the ESP to run the robot in omnidirection. So that was about it from the application. And if I just show a simple demonstration of deleting a device, I can delete a device at any time. And like, oh, also if I delete my robot, it will say app has been disconnected and restarting a scan. And if I go and scan for the device again, I can see the robot, I can see my saved robot, and after I log in, after I select it, the app gets connected. So this is the overall explanation of how my project runs, and this interface works for various robots. For example, if we have a hexapod, it will work on based on the joysticks and do its designated jobs using the buttons. Or if we have a car, or if we have a robotic arm, these buttons will be programmed accordingly. Like it will send commands accordingly to the code of the robot, and the robot will move based on these commands. Like if I press the upward arrow key in my keyboard, and it's a car robot, the car will move forward, and if I press backwards, the car will go backwards. This is how these buttons will be defined on the robot. So this is the overall explanation of my application. Now I'll move to the code. So yeah, if we go back to the code and explain how the code works, and let's go here. So I have used the room database. I am using the room database in this page to keep store of my robot profiles, and in robot entity was that file. The robot profile keeps track of all the robots I have previously inputted, and the repository keeps track of the robots I have already stacked in my list. For the Bluetooth connection, I have used this one, the Bluetooth connection manager. This page, this snippet of code contains the Bluetooth connectivity. Here in the connect function, we call device.connectGet. It's here. Yep. Where is that? In the connect function, this part calls the device and connects to it. If we scroll down to the callback, you will see on connect, where is that? If we go down to the callback, you will see on connect state change. When the state switches to connected, I immediately call discovered services. Where is that? Here on services discovered, I immediately call discover services, and this is crucial. Without it, crucial. Without it, we can find the characteristics to write data to. Once the service are found, I look for a specific UUID. This UUID acts like a secure channel between my app and the ESP32. If I see the ESP32 code here in the terminal of this, I can see it has a specific. Every ESP has a specific specific. What's that called again? The MAC, a specific MAC address. So the application and the robot communicates using that MAC address. For the UI, I use Jetpack Compose for joystick. The joystick isn't a standard button; it's a custom drawing on a canvas. I use pointer input with detect drag gesture. It's in dashboard screen. Yep, it's in dashboard screen. And if we see here, as the user drags, I calculate the Euclidean distance from the center. If the distance is less than the radius, the knob follows the finger. If the distance is greater, I use vector normalization to clamp the knob to the edge of the circle. I finally map these pixel coordinates to a percentage of -100 to +100 and send that string to the connection manager. It's all done in here. The dashboard screen. This one is, adds the new buttons, and this is the padding for the joystick. This whole part is for the joystick, how the joystick works and all. On hardware side, the code is written in C++. The Arduino IDE code. This one. So this one is written in C++ and a basic robotics code. To summarize, the Android app captures touch input, mathematically processes it, and sends it via a GATT characteristics, characteristics, and the ESP32 parses that string to connect the motor drivers physically and do its job according to the code. So this is my presentation of my project of cse489. Thank you for your time.